In this problem, we're going to look at how to solve systems of equations. What's a system of equations? That's really just two or more equations where we put them together and we see what they equal. If we have just one equation, of course, that makes a line. So for this one, the top one's going to be something like that. And this bottom one here is going to be something like that. So the one place where they're both equal is right there. Now we can guess that by graphing. That's going to give us an approximate answer. Or we can solve it analytically. And that's what we're going to do. Different ways we can solve this. One way we could do is set y equal to y in this case. We simply get 2x plus 3 equals y. Y is the same thing as this. So minus 3, x minus 1. Okay, so we add negative 3 to both sides. As long as we do anything we want, we're going to do the same thing to both sides. Okay, negative 3 plus positive 3 cancels itself out. Here we have 5x plus 3 equals minus 1. Okay, let's add 1 to both sides. So we get 5x. Oh no, I don't want to do that, sorry. That would make it too complicated. We want to subtract 3 from both sides. So that would give us minus 4. Then I divide both sides by 5. X equals minus 4/5. Okay, now that I know what x is, I can come up here and plug it into one of my x equations to get y. Okay, so I would take I'll take this top equation. It doesn't matter which one I grab. Both equations are true. We know what x is. It'll be the same either way. So I can plug it into this one or plug it into this one. Does not matter. Okay, so 2x. X is minus 4 over 5 plus 3 equals y. Okay, if I multiply that out, I get negative 8 over 5 plus 3. If I put 3 in fifths, that is 15 fifths. Negative 8 plus 15, that's going to give me 7 fifths. So 7 fifths equals y. So we have our xy pair is minus 4 fifths, 7 fifths. And that's about what we guessed earlier. When we had it graphed, we guessed it was going to be something right about there. And that would be about right. Okay. Now that's the, they don't always come this simple. We can solve them more complicated. If I, for instance, had a complicated function here, y plus 3, let's make that different. 5y plus 7. Then I could have solved for y, or I could have taken this equation and done what we call substitution. I would have replaced that y with this number. It would have looked something like this. So I could have put 2x plus 3 equals 5. And instead of y, I put what y equals, which is minus 3 minus 1 plus 7. And then simplify and solve from there. I may do a more complete video on substitution later. That's the gist of substitution. Another common method is to take both of these equations, multiply, we want to cancel out the x, so I multiply this one, 2x times this whole equation times 3, and since I want the same thing to cancel out here, I multiply this times 2, so this would mean I would get a 6x for right here, and a negative 6x here. So then when I cancel out terms, I add these two things together and cancel things out. 6x, negative 6x cancels out, and we have left as a function with y. Solve for y, and you're halfway there. That's the other popular method.